Greetings, learners. Welcome to another math session. In this session, we'll be looking at the number patterns. For this question, we'll be looking at the arithmetic number pattern or the linear number patterns. So we are given the first question here, which is 3.1. So we have to consider the pattern that we are given here. For 3.1, we have the first term here that we are given, which is -1, and then a second term is 2, third term is 5, the fourth term is 8. Okay, and this number pattern goes up until 116. Okay, up until 116. Okay, so for 3.1, they ask us to determine or write down the term 4 and term 5. So for term 4, it's easy. We are given term 4 here, which is 8. So term 4 is 8. This is simple. Okay, let me write it here because I want to show you something. So for term 4, you have 8 because you can see 8 is is positioned at term 4 here. So the value for term 4 is 8, and then the value for term 5. What is the value for term 5? So we can see this number pattern has a constant difference. How do we see that? Because we can see here term 2 minus term 1, and term 3 minus term 2, term 4 minus term 3, they all have a constant difference. So 2 minus 1 is what? 2 minus minus 1. So 2 minus -1. In other words, 2 minus -1, that is 3. So this is a bit confusing. Let me try to write it here so that you can see. So it's 2 minus -1. So what do we have? This becomes a positive. Now you have 3. So that's why 2 minus -1 is 3. So the next one, we have 5 minus 2 is 3. 8 minus 5 is 3. So we have the constant first difference of 3. So if we have to find the next term here, we need to add this 3 to 8 here. So it means also here is the constant difference of 3, and then it means the next term we need to add 8 plus 3, which is what? Which is 11. So it means the next term has to be 11 here. So term number 5 will be 11, right? Okay, and then for 3.1.2, they want us to determine the general formula of the nth term of the sequence. We know our Tn, it equals to An plus B, right? So this helps us to determine the general formula. So we know that our A is what is the constant first difference, which is 3. And then Tn is the value of the term. So it's either the value for the first term, the value for the second term, third term, fourth term. So you choose. In this case, we can choose the first term. The value for the first term is what? Is -1. And then this will equal to A. What is the value for A? The value for A is 3, right? Because remember, 3 is the constant first difference. And then N plus B, right? So, but here for N, you know that the first term, which position is the first term? The first term is on position 1. So it's 1. Our N is 1 on the first term. So we can quickly solve the value for B, because we can see that -1 will be minus by what? 3, right? Because this 3 will be -3 when it goes to the left hand side. And now we have what? We have negative 4. So what happens next? We write the whole general formula. So our Tn will equal to 3a plus b. Our b is what is 3n plus b. Our b is negative 4. Okay, it's negative 4. So this is our general formula, right? This is our general formula. Okay, so what do we do? We are done with this question here. We move to the next one. So for the next one, they ask us to determine the term 33 of the sequence, right? So the 33 term of the sequence, we just simply substitute on this equation here. So it will be 3 into 33 minus 4. So what do we have? We can quickly use our calculator. So 3 times 33 minus 4. Okay, so we have 95. So 95 is our answer here. So our answer is 95. So for 3.1.4, okay, they want us to determine or how many terms are in the sequence if the last term is equals to 116. So we can see here the last term equals to 116. So we want to know how many terms does this sequence have. So we know the general term, which is Tn equals to 3n minus 4. So the last term, right, we're given that is 116, and then 3n minus 4, right? So we need to solve for n to know how many times uh, uh, our sequence has, right? Because we're given the last term here, we need to know the total number of uh, the total number of terms that are in our sequence. So from here we have 116, and then minus 4, it becomes positive 4 this side. So it's 3n, right? So we can see that we'll be left with 3n equals to 120. So we just need to get rid of these 3, can divide by 3, and also divide by 3 so I don't have enough space here. And then you'll have what? You'll have a 120 divided by 3. Okay, so 120 divided by 3, it will give you 40. So it means that in the number pattern that we have 40 terms. Okay, so moving forward on to the next question, 3.2. So for 3.2, I'll write it on this side. Okay, so I'll continue on this side for 3.2. We are given a linear number pattern with a constant difference that can be expressed in terms of x plus 3, x 3x plus 2, 6x minus 1. So this is the first term, this is the second term, this is the third term, right? So we can simply write it down. So we have x plus 3, 3x plus 2, and then we have 6x minus 3. So this is term 1, this is term 2, this is term 3. So for arithmetic sequence or linear number pattern, remember your t always, your T2 minus T1 will equal to T3 minus T2 always. So this is the formula. You have a constant first difference. So your the difference between the second term and the first term will equal to the difference between the third term and the second term. So what is the second term? Our second term is what? Is 3x plus 2 minus the first term, which is x plus 3. So you need to be careful when you put your brackets here. You need to make sure that you put brackets here before the negative number or the number that you're minusing with, so that you can multiply everything by negative, right? So please don't forget to put brackets here. And then term 3, you have 6x minus 1 minus 3x plus 2, right? Also, you put brackets here because you have two terms. So now you solve and group the like terms and solve. So okay, so we have a negative here. Let's get rid of the negative first. So we'll have 3x plus 2, and then this one here, negative multiplied by x, you have negative x, and negative multiplied by 3, you have negative 3 equals to 6x minus 1. Negative multiplied by 3x, you have negative 3x. Negative multiplied by 2, you have negative 2. Okay, now you group the like terms. On the left hand side, you have 3x and negative x. This will give you what? This will give you 2x. And then here you have what? You have 2 minus 3, which will give you negative 1. So you just group the like terms. And then here, 6x minus 3x, you have what? You have 3x. And then the other one, you have negative 1 and negative 2, right? So you have negative 3, right? You have negative 3. Okay, so here you group the like terms again. You have x, 2x here and 3x here. So 2x minus 3x, and then you have negative 3 plus 1, right? So what do you do? Okay, you add this like terms here. So negative negative, I mean 2x minus 3x, you have what? You have negative x. And then here, negative 3 plus 2 is negative 2, right? And then it means that your x will equal to 2. Okay, so it means that you have found your value for x. Then the next question here, or the next step here, they want you to find the numerical value for the third term. So the third term is 6x minus 1. So T3 is 6x minus 1, but you already know your value for x, right? So x is 2, so it will be 6 times 2 minus 1, which is what? Which is 12, minus 1, which is 11. So your term 3 will equal to 11. Okay, well done, learners. We have come to the end of today's session. Please don't forget to like and subscribe, and I will see you on the next lesson. Thank you.